Hello everyone. So in our previous video, we discussed about the idea behind how the cadence algorithm work in finding the maximum sum subarray. So in our previous video, we actually discussed the idea behind the algorithm. We saw that how current max and max so far or the best sum help us in determining the maximum sum subarray in this given array. And we also saw that we traverse the array, and on each element, the element decides that should it be part of the current subarray or should it start a new subarray. So now let's see the demonstration of this algorithm step by step. So here you can see that we have been provided with an algorithm which is the cadence algorithm. So usually the method name is max subarray sum. It takes in an integer array and finds us a maximum sum for any subarray in this array. So let's see the demonstration of this algorithm step by step. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So at the start, let's say we provide an array as what we discussed in our previous example. So usually at the start, the first element is simply taken as max so far and the current max. So max so far is 4, this value, and current max also becomes 4. Now the algorithm basically starts with second element. So here I starts from 1 and goes till array.length. So here array.length is 8. So I will travel from 1 to 7 because 7 is less than 8. Now on this point 3 has two choices. Either it should become a part of the current subarray. So the current subarray is this. Or it should start its new subarray. So as we discussed in our previous slide, what we do is we take current max and we add the value stored at the index of I and we assign it to the current max. So here we are simply taking the current element value and we are adding it with the current max and assigning it to the current max. So it means 3 decided to go with the 4. It means 4 plus 3 will give us 7. So 7 is assigned to the current max. So current max becomes 7. Now why we directly assigned it? Because in the next step, this current max is actually compared with the element's value. So this is our second question, that should I start my new subarray? Here this part was where element decides to go with the current subarray, and in this if block there is our second question, that should I start my new subarray? So if current max is less than the value of the current element, then we simply assign this value to the current max. So here 7 is compared with 3 because array of I is 3. So whichever is the bigger value is simply assigned to the current max. So 7 is the bigger value among these two values. So current max remains the same. So friends, here you can see that when element decides to be a part of current subarray, we simply add it to the current max. And here we are simply assigning it to the current max because in the next step we will reassign it if current max is less than the current element's value, which means that 3 has decided to create its own subarray. So this is actually our question 1 and this is actually question 2. So whichever wins, that value is assigned to the current max. And if this condition comes out to be false, then we do nothing with the current max because we have already assigned current max plus array of I to current max, which is 4 plus 3 equal to 7 to current max. So now this value is included in the subarray. So the current max is 7 being formed from the subarray 4, 3, which is these two elements. And now we'll simply compare this sum, current max sum, with the maximum sum so far. So if max so far is less than current max, we simply assign the current max value to the max so far, because current max actually beats the maximum sum so far. So here max so far is 4 and current max is 7. So this condition comes out to be true and max so far becomes 7. So here this is current max and this is max so far. So at the start it was 4, then it became 7, taking in 4, 3. Moving ahead, now we'll increment I by 1. So I points to the second index. Now this minus 2 has two questions, that should I become part of the current subarray? So we simply take their sum, current max plus array of I. It means we are including array of I. So here it will become 7, which is the current max, plus minus 2. So 7, which will give us 5. So current max will become 5. And then this element simply asks that, okay, can I start my own subarray? So this check actually decides that if current max, which is 5, so if it is less than array of I value, which is minus 2, so array of I value is simply assigned to current max. So this condition comes out to be false because 5 is greater than minus 2. Then we simply check whether max so far is less than current max or not. So why we are doing this check is, we are simply keeping the track of the maximum sum so far. So if at any step current max becomes greater than max so far, it means we have found the maximum sum so far. So we simply assign current max to max so far. So as of now, max so far is 7 and current max is 5. Therefore this condition comes out to be false because 7 is not less than 5. So here the current max will become 5, taking in 4, 3 and minus 2, and max so far will remain same. So now we'll increment I, and here you can see this element has been included in the current max subarray. So friends, here you can see, as we know that each element asks two questions, whether it should become part of the current subarray by simply adding its value to the current max, or they decide to create their own subarray. So this piece of code decides that. So you can also think this piece of code as something like current max equals, we can also write something as math.max, and the two values would be current max plus array of I or array of I. So whichever is the maximum value, we simply assign to the current max. So this is question 1 and this is question 2, that should I become part of the current subarray? If that is maximum, that value is assigned to the current max. Or if element decides to create its own subarray, so it's simply its value is assigned to the current max. So either we can do this or we can do this, that first we directly assign current max plus array of I value to current max, and then with this if block we reassign the array of I value to current max if the value at ith index is actually greater than the current max. So it means this value is greater than current max plus array of I. So this value will be assigned, or else we have already assigned this value to current max here. So now value at ith index is 6. So we simply assign phi plus 6, which is 11, to current max. So current max becomes 11. and then we simply decide that whether current max, which is 11, is less than the value 6 or not. So if it is less than 6, then we simply reassign current max to the array value at add index. So this condition comes out to be false because 11 is greater than 6. So here 11 is our current max. We have taken these 4 values. Now we'll simply compare that whether the maximum sum so far is less than current max or not. So here you can see 7 is less than 11. It means we have found a new max so far. So we simply update current max to max so far. So it becomes 11, 4, 3, minus 2 and 6. So it means we have found a subarray of max sum as 11 having these 4 elements. So now we'll continue with the rest of the elements. We'll increment I. So I will now point to the 4th index. So here array of I is minus 12. So here we are simply adding current max, which is 11. It will give us minus 1. So current max will become minus 1. And then this element will decide that can I start my own subarray. So it will compare its value, which is this part, with the current max, which is minus 1. So minus 1 is greater than minus 12. So this condition comes out to be false. And the current max, which is minus 1, is actually less than max so far. So this if condition also will come out to be false. So max so far will remain 11, which makes sense because a subarray whose maximum sum is 11 is being found from these 4 elements. So here we simply write 11 only, 4, 3, minus 2 and 6. Moving ahead. So here minus 12 has been included in the current subarray. I will now point to index 5. Current max will become minus 1 plus 7, which is 6. So this is the part when array of I decides to go with the current max. And then it checks, okay, can I start my own subarray? Because my own value is 7. But if I go with the current subarray, the current max is 6. So therefore it decides that it's better I create my own subarray, because if I create my own subarray, I will give a sum of 7, and if I go with the current subarray, the sum will be 6. So therefore this condition decides that the current max is 6 and it is actually less than 7. So the current max will become 7 by simply assigning array of I to current max, which signifies that 7 has decided to go and create its own new subarray. So current max becomes 7. So now this subarray will be removed. And from here a new subarray will start. And here we will simply denote 7 by taking in only 7. And this current max doesn't beat the max so far. So this condition comes out to be false. Now we'll go to the next element, which is minus 1. So here minus 1 will be added to the current max. It will give 6. So current max will become 6 now. And now this minus 1 will see that if I become part of the current subarray, which is this, I am getting sum as 6. If I start my own subarray, I will get sum as minus 1 because this is the only element. So it sees that okay, it's better to go with the current subarray. So this condition comes out to be false because current max, which is 6, is actually greater than minus 1. So here now our current max is 6, taking in 7 and minus 1 together. Now this 6 doesn't beats the 11, so it remains the same. Now we'll increment I. So now I will point to the 7th index, and here this current subarray has included minus 1 with it. Now we'll simply add the value 6, which is this value, with the current max. So 6 plus 6 is 12. So current max will become 12. And this 6 also checks that if I start a new subarray from here, what's the sum? So this is the only element, so sum is 6. So it doesn't beats the actual current max. So this 6 decides to go with the current subarray by adding itself to the current max. So this condition comes out to be false because current max is 12 and it is greater than 6. So now this element is included in the current subarray. So the current max is 12, taking in 7, minus 1 and 6. And here you can see that this current max 12 actually beats the max so far. So this condition comes out to be true because max so far is less than current max. So it means we simply update the max so far, which is 12. So this value is assigned to the max so far, stating that this sum was made from this subarray. It becomes 12. We'll increment I. So this for loop will exit because now value of I is 8 and 8 is not less than array.length. It is equal to array.length. So it means we have traversed this array completely, and at the last we will simply return 12 because this is the maximum sum so far created by a subarray, this 7, minus 1 and 6. So this 12 is returned. So friends, here we saw that there was one subarray 4, 3, minus 2 and 6, which actually gave the sum as 11. So this subarray was max so far for most of the time, and at the end this subarray, whose total sum came out to be 12, became the max so far. So 7, minus 1 and 6, which gave the sum as 12, was the maximum subarray sum, which we finally returned from this method. So friend, this is how the cadence algorithm works. So here one more question arises, that why we are actually taking in the negative values in the current max like we did here. We included minus 2 and the current max became 5 from 7, because here you can see that current max value is 5 after including minus 2. If this value would have been, let's say, 1000, so in the next iteration, if we have included 1000, we would have got 1005 because we will be adding 5 to 1000. But if we would have discarded this value, so from this part a new subarray would have been started, which only would have given 1000. So we are not sure what next element is coming up. So therefore we have included -2 because this value is less than this value. So therefore we have included -2 also because we are not sure what is coming up. There could be a very large maximum value which would have raised this sum to 1005. And if we would have discarded -2, so this subarray would have been ended here and a new subarray would have started here, which only could have given a sum as 1000. I hope you must have liked this video. And in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.